English lecture. This lecture will be delivered by Professor Surjakanta Pal, a professor in the Department of Mechanical Engineering at IIT Kharagpur. He has held the position of Kumar Bhattacharya Chair Professor in Manufacturing at IIT Kharagpur. He is the founder of Chairperson of Center for Excellence in the Advanced Manufacturing Technology, a research platform for solving industrial problems. In addition to his role, served as a visiting professor to the University of Connecticut, Lehigh University, USA, and the University of Oxford in UK. He has published 328 research papers, including 207 international journal papers, 4 national journal papers, 15 international book chapters, 97 conference papers, and 17 patents, and 1 copyright filed. Professor Pal has supervised 24 doctoral students, and 13 are currently working. His Google Scholar citation is 9341, and his H index is 55. His innovation, low-cost AI solutions for meteorological inspection is selected in the top 3 by India at Large to Market, the National AI Portal of India, Ministry of Information and Ministry of Electronics and Information Technology, NAGD NASCOM initiative. He is author of the textbook Digital Crime, Fundamental Concepts to Applications in Advanced Manufacturing. Professor Pal has successfully executed various sponsored research projects, and it is value-wise close to 98 crore. As a part of administrative duties, he also served as the Associate Dean of Alumni Affairs, IIT Kharagpur. He was the chairman of the Steel Technology Center, IIT Kharagpur. In recognition of his outstanding contribution to the science and technology, Professor Pal has been awarded the prestigious Fellow of Indian National Academy of Engineering. He has been featured in the research.com as the outstanding researcher, top 1% of leading scholars in mechanical and aerospace engineering, with 8th national rank and 932nd global rank in 2024. Professor Pal has been selected as one of the top 2% most cited scientists as per the database published by Stanford University in 2022. He has also featured in the top 2% scientists in mechanical engineering by Alfred Dogger, AD, Scientific Index in 2024. I know him for a umpteen number of years now. He's really an asset to IIT Kharagpur. And of course, I'm not really going to talk much about the topic in which he is going to, present. He will really do it. And but one thing I can say, he is one person who is both in the academic as well as with the industry. A rare combination of people. Those who are in the academic, they don't think that we should be away from the industry. But it is not the other way. That is outdated concept, and he is one such person. Now, I will actually request, because this distinguished lecture is being jointly organized by INAE Bhubaneswar chapter, SOA University, IMMT Bhubaneswar, IIT Bhubaneswar, and NISER Bhubaneswar, plus IEEE Bhubaneswar chapter. Not jointly, actually, we do this. So here, actually, we have our Honorable Vice Chancellor, Professor P.K. Nanda. He may like to say a few words about our university.
Thank you, sir. Good afternoon, esteemed Chairman of our advisory board, Professor Damodaracharya. Also, he's Chairman of Bhubaneswar INAE chapter. Distinguished guest today and speaker, Professor Pal from IIT Kharagpur, and all the distinguished members of the INAE, fellows of the INAE, and Dr. Renu Sharma, who is our additional dean SA and the coordinator for this talk, and also the directors of all our collaborating institutes, IIT Bhubaneswar, IMMT, Niger, and also IEEE Bhubaneswar subsection, and all others. So this is our privilege to have you with our continuously. This is a kind of a talk series, which I think our esteemed chairman, Professor Acharya, is organizing and grouping in all top scientists of the country. So our university started in 1996 as a college, became university 2007. And I think we are offering 10 disciplines, different programs, including veterinary science. We added medical science, engineering, management science, pharmacy, biotech, nursing, agriculture, law, and veterinary we have added. We have a very strong footprint in engineering as well as medical science, 2 flagship institutes. This year, our ranking, NIR ranking, is 14th among the university category and 24th among all the institutes in the country. And our medical science ranked 21, and engineering is 26th in the country. 2 of the institutes, dental and law, they are in top 10, 9th rank, and management science 57. So we are progressing well, and we have established good kind of the ecosystem of academics and research in our university. Thank you, sir. Thank you.
Okay. Now, anybody else actually who is there from our sister institute? So now I'll request Professor Pal to please present your.
Yeah, I'll share. So let me share my screen. Hope the screen is visible to you. And also my voice, I think I'm audible to you. Is it clear? Can you say just yes?
Yes, yes.
Yes, yes, sir. Yes.
Yeah. Thank you. Thank you. So first of all, good evening to all of you. And this is a different kind of feeling today I'm having. Two stalwart, the teachers whom I observe very closely, Professor Acharya and Professor Bisra, both of them are present today. So it's altogether a different feeling. I cannot express that, that joy. Now coming back to this, before I start discussing about the topic, I'd like to thank this great initiative that all major the universities and the institutes of the Odisha, they have come forward together, jointly organizing this webinar series. This is really, really very good. And I'm pretty sure, though the attendance today is not very, the high, but if it is recorded and circulated, it will definitely create a sensation, across the research community. And it will bring people to, the closer and closer. Now, I've chosen this topic when Professor Acharya requested me. I had chosen this topic, that human-centric manufacturing, a new era. It would be very appropriate today, because everyone is talking about the industry 4.0, the artificial intelligence and automation. And the industries have also started, adopting the industry 4.0 concept. But they are also realizing that industry 4.0, or the full-fledged artificial intelligence model, how much it is effective and what are the challenges or the concern, and how much progress it can bring in. Is there any need to bring back human again in the activity loop? that is basically a thought process of the industry 5.0. So I'll be mostly concentrating on that. So AI, artificial intelligence, is not a buzzword today. It has got the tremendous, the power or the potential. So if we see the functionality of the human brain, the AI, artificial intelligence, is just trying to mimic that functionality. It is basically trying to mimic that functionality. That means the functionality of the different portions of the brain, which is getting decoded by the neuroscientists, through different types of the experimentation, and computer science or the people from the mathematics or related background, they are trying to develop the artificial model mimicking those functionality. And we, the manufacturing, if I consider myself the manufacturing, the researcher or the the people in the industry, we are trying to deploy it. So the depending on the type of activity that I need, I am deploying the artificial models and putting its the different inputs, relevant inputs. The inputs could be in the form of audio, text, language, or image for visions and all. And then we are trying to see that how much, what is the performance. But if we look very carefully, these models are case specific, the applications. So that means for a particular applications of manufacturing or any need, so we are trying to deploy that model, and we are trying to see that how much is the performance. If the performance is not up to the mark, we are going back to the model, fine tuning it, and again running that one. So these models, if I see carefully, and all of you will appreciate that they are very much case specific. So for case specific models, sometimes they outperform the human being, and we have seen the example of the AlphaGo, that is this AI software which can beat the world most strongest or the toughest the chess player. But if you look carefully, the development of the AlphaGo and the amount of expenditure spent, amount of resource that we have used, it is very, very high in number. So whereas, and human is very much dexterous, human can do multiprocessing, the work. So we need to come up with some model which would be very, very generic, or which would be covering large amount of the activities or the aspects of the concerns of the industry. If I see this industrial, the shop floor, if you all of us know that there are many types of activities involved. There would be the movements of the workers, discussions among the workers, movements of the vehicle, the different types of the data is collected, human robot collaboration is happening, forecasting is being made, solutions are coming up, and based on all these activity, based on all this insight, we are also dynamically optimize the warehouse activities and also going for the predictive maintenance. Now, as of now, it is very, very difficult to capture the insight of all the activities and bringing them together one under umbrella and taking a holistic decision. What we are doing is that we are understanding what particular concern, developing a model and working on that. Now, we all know that these integrations among the different entities or the information coming out of the different stakeholders and putting them under one umbrella has been, it is a challenge right now, and it will be a challenge. So our aim is to come up with a very, very holistic model. Now, as I mentioned just now, that industrial work is very much, there will be several activities involved, like the task 1, task 2, task 3, and several tasks depending on the type of industry. And they would be also pretty much interdisciplinary in nature. So we are collecting the information for the different tasks through the different the sources, like by using the different types of the sensors, getting the different forms of the data, developing different models. But how to optimize a single model, interacting all these, the sub AI models. That means the capturing the physics of the entire phenomena happening and developing an AI model, optimizing that is a challenge as of now. And on top of that, this is very much true for any of the industries. On top of that, we also observe those who work closely with the industry, they will be appreciating that there is a tremendous need of the data for each and every activities of the AI model, but at the same time, getting the huge amount of the data or the record amount of the data for an industry will be very, very difficult. If I want to develop an AI model to predict the health of the machine, and for that, I need to have the different types of the data, like the healthy machine, unhealthy machine, and let's say the weak machines, and all sorts of combinations would be coming up, and the data requirement would be happening. But industry may not be having the data captured, or maybe having a new machine. Still, they want to go ahead with the predictive the maintenance plan for that machine or the critical asset, but they don't have the data for the faulty situations or the unhealthy situations. So how to generate the data? On top of that data, there will be a lot of uncertainties and complexities involved. As I mentioned, that it is very much interdisciplinary in nature. Because of all these activities and also the lack of real-time deployment of the artificial intelligence model, because some of the models take a lot of time, some of the models is unable to capture the physics of the entire the process. That's why sometimes we need to go for the simulations. So clubbing the simulation data and the sensors data and developing a model and deploy it in the real time has been a challenge. So the data and complexity, the issues we need to overcome. So having said that, it has been a concern for the industries. Many of the industries, they do have the legacy machines, and Industry 4.0 concept has come recently, maybe 2011, 2012, 2014. In that period, it has come. So 10 years back, a decade back. But industry, and this concept is based on the sensor based data capturing and implementation through the AI model. That means the old machines, the legacy machines, they won't be thrown off, they cannot be thrown off by the industries and purchase the new machine. So how to integrate the modern digital concept onto the legacy machines or the old machines has been a challenge, specifically for the micro, small, and medium enterprises. More specifically, country like ours in India, because if you observe the micro, small, medium enterprises, they do have one machine. That machine may be getting run over the decades, maybe over the generations, making a little bit, the small incremental changes made in the system or into the machine. So if we ask them to throw it off and purchase a new machine which would be Industry 4.0 compliant, that would be very, very difficult. At the same time, the domain expertise, if you want to develop or deploy the AI based model, artificial intelligence model, complete artificial intelligence based model, you must have the complete domain expertise. And at the same time, you must be clear about how to deploy these AI technologies into your model, onto your machines, which may not be the very convenient situations for the Indian industries, more specifically the micro small. Throughout the seminar or the presentation, many a times I'll be talking about the micro, small, medium enterprises, because it's a real burning issue in India, and I've been interacting with many small industries and become failure. Whereas my success rate with the big industries are quite, promising. At the same time, the data security, I'm getting so much of data, how to secure them, how to make it private. And at the same time, the data which you are collecting through the sensors, how do you ensure the data is of good quality? Because if the data sanctity is not there, and if you develop an AI model based on assuming that data is of pure in nature, and then finally AI model predictions may not be the good. So having these concerns like the legacy machines, integration, domain expertise, and all data security and data quality, still statistics says that 70%, close to 70% of the companies executives, they think that the AI will be doing better in the future. And that's why there is a promise that 3.7 trillion US dollar would be invested in the field of AI for manufacturing by 2035. We are standing today at 2024. That means 11 years down the line, already investment has got started. And 11 years down the line, that investment on AI for manufacturing will be pretty high. And that's why a lot of startups are coming up, industries are they started thinking, mindset is going to get changed. But still there is a fear. 36% industry feel whether AI will be able to do their job effectively or not. And these 36% does include more specifically the micro, small and medium enterprises. So if I want to develop an AI model, which should be very, very holistic in nature, capturing the integrity of the system, and at the same time, it would be very much generic so that it can be applied. The knowledge which should be learned, that can be easily transferred or applied to the other similar system. Then AI has to have a conscious, the machine has to have some sort of a consciousness. If I give this image to ChatGPT or similar software, very easily those AI-based software would be able to tell that it is the image of a particular the occasion, that is a birthday, and they would be able to count that how many people, how many girls are present, who is the birthday girl, what is the color of the dress, and all these things they would be able to tell. That means whatever is seen very clear from the image, AI can very easily perceive that. But if something is hidden, something is unheard, something is unseen, AI finds the difficulty, as of now, finds the difficult to depict or extract that. It is very difficult for the AI model to tell what could be the possible conversation between the two girls at the center, or what is the thought process of the little girl standing on the left hand side. If I ask a human being can very easily tell that the possible conversation could be the how many the one girl is asking the birthday girl, the how many toys you have got today. Is there any new toy that you have got? Can we play together tomorrow sometime? Which is very, very difficult for the AI model to predict. That means AI model has to have a real intelligence, human-like intelligence, which we call it as a conscious machines and all. But having all these challenges and promises, that's why the research continues, technology gets evolved, but still there is a concern. Let us see what is the concern. If we look into this industrial the revolution, starting from the industry 1.0, at the advent of the usage of the steam into the as a the energy provider to the machines and all, there is a economic growth, and economic growth is constantly, continuously happening. Whenever there is a slight fall in the economic growth, and then new technologies has been thought of or deployed to boost the economic growth or the GDP in the manufacturing. And because due to this, starting from the industry 1.0 to today, if we see that the too much of automation has taken place, and that's why the job displacement has got started. Lot of robots have got started, the using it. Overall 15%, the job got displaced out of 400 millions, this. And India is also not lagging too behind. 9% job has already got displaced. So economic growth is happening, automation is coming up, job displacement is happening, and at the same time, if you see that the environmental impact, that is also is a concern. CO2 emission has got increased a lot. That means there is a concern of the sustainability. Very quickly, let us look into this, the revolution, and what is the promise and what is the impact. When the industry 1.0 revolution concept came up, that means the steam started using it, and the people started moving from the rural area to the urban area, and mostly the riverside urbanizations got happened. So people started living there, But as a result, what is the social impact is happening is the harsh environmental condition, too much of water pollution. Then with the usage of the electricity, lot of productions, productivity increases, demand also increases. If you look carefully, the consumerism started actually from the era of the industry 2.0, when the electricity got started and mass production came up. So that would be again the social impact is that the air pollution became very, very high. So economically, we are becoming more green, but the socially, both in terms of the human impact and environmental impact, we are going into the red zone. And when the industry 3.0 era came up, that is the robots came up, lot of globalization happened, entrepreneurship happened, innovation happened, but the job displacement started. I've already mentioned that the 9% of the jobs in India in manufacturing industries got replaced. In manufacturing industries, I'm talking about, got displaced by the robot. So the job displacement started. Now, robot means the computer, processor, sensor, PLC, all these are electronic devices. So all these electronic devices are also getting dumped into the soil. So that means the soil pollution, that came up. So first we had the water pollution, then the air pollution, and now we are ending up. We are, the soil pollution got started because of the dumping of the electronic equipment. Then today we are standing in the industry 4.0 era, which is the cyber physical system. That means all physical systems are connected by the cyber, means the internet. What does it mean? That means we are acquiring more amount of the data. If the system, all systems, you think of any manufacturing shop floor, there is a milling machine, drilling machine, and then let's say the lathe. If all these machines are connected by the sensor, that means huge amount of the data would be collected from each of these. And if we can store them in one place in the cloud or in the remote or in the edge computer, that means you get getting more and more, the insight. But what is happening? Our privacy is also getting lost. Today, you can see that all of us are getting traced. All of us are getting traced, that each moment what you are doing and where you are. That means privacy is getting lost. There are a lot of ethical issues are coming up. And recently, Forbes had made a survey, and the survey says that 66% of the world people, 8.1 billion is the world population. So 66% of that are using internet. See, just feel that number so high. And out of those 66%, 6.5 hours a day people are using on an average on internet, and that is mostly on the social media. What does it mean? It means that we are too much on internet. So already on, that means 1/4 of our daily time, that is the 24 hours, more than 1/4 of that we are spending on internet. If we spend more and more time on internet, our intellectual capacity or the capability is also decreasing. And this lecture I had already given in TCS, Tata Consultancy Services, and day before yesterday at the Research Scholar Day at Cryogenic Engineering Department. And I told the students, research scholars, if I ask you what is the pin code of the institution where from you have graduated, you will not be able to tell, but I'll be able to tell that. So that means we are not memorizing anything. We are not keeping anything in our mind. We are not working on the data by ourselves. We are leaving everything onto the computer or the AI model to work for us. If it is done in that way, gradually the intellectual capability or the thought process or the thinking power of the human being over some, after some decades would be very, very less, and people will be in very much danger. And that's why myself, I have, coined this term that we are in the cyber pollution today. So you see the industrial development, the revolution started the water pollution, air pollution, soil pollution, and today we are in the cyber pollution system. But it doesn't matter that which industrial revolution has brought which type of pollutions or created which type of pollutions today. If I club them all together, if you see, We are having cyber concerns. We are having economic disparity. We are having the social implications. We do have also the environmental issues. And we are also perturbed by the too much of automation over human being. And all these issues, if you see very clear, read this, the bulleted points, these are really, really, the concern. And as a researcher, I mean, I myself, the all the time, I think that at least if I can mitigate one of the concerns of these so many concerns through our technological development, then that will be a success. We can call it as a success. I'll be more than happy to do that. I'm having too much of publication, too many publications. This is good. That's the number. But I'm not very much happy still after achieving this, unless I mitigate at least one of the problems through our technological, the deployment. That's why, if you look very carefully, even Elon Musk has also appreciated that too much of automation for the sake of automation is not good for the society. Society should not be, industry should not be always, the productivity oriented or the progressive based. So let us look into this, the statistics and all. Very, very interesting. 2008, all these things happening in 21st century. 2008, we all have seen that the Great Recession, IMF declared Great Recession. As a result, the severe economic and financial meltdown happened. A lot of job crisis also, that came up. 3 years later, Germany first came up with the concept called the Industry 4.0. You see, that means whenever there is an economic, there is a stagnation in the economic growth or fall in the economic growth, the new technology is coming up. So in Industry 4.0 is a concept that industry, the automation concept that came up 3 years later than 2000, from 2008. But 6 years after usage of this, the Industry 4.0 deployment, people started feeling a concern. Japan, 2017, first came up with a concept called the Society 5.0. Japan thought that, are we really doing good by going ahead with the solely the concern of the Industry 4.0, which is the profit making concern or the profit making the idea or the progress based idea? Should it not be the technology which can bring sustainability, technology which can bring inclusivity, technology we can maintain the socio-economic parity in the system? So Japan, 2017, it came up with this concept called the Society 5.0. 2 years later, we all have experienced the great lockdown. Who declared the great lockdown? And just during that period, OECD declared society or the economy must be the well-being. That means mutual development for the human as well as the sustainable economic growth. And that's why 2 years later, the European Union declared that by 2030, that means 6 years later, the all industry must be Industry 5.0 compliant. What does it say? It says that the industry must be human-centric, the industry must be sustainable, industry must be resilient. These three terms are very, very critical, and next few slides I'll discuss about that only. Human centricity, sustainability, and the resilience. Now, you see, all these things are happening in 21st century. That the concern is that the 2017 Japan came up with the concern, and then 2021 the European Union told that mandated the industry must be the human centric. But see the vision of the researcher. The great Professor H.H. Rosenbrock, who was a faculty in MIT and then Cambridge, and then finally before retirement he was there at University of Manchester. He wrote a book in 1990, Machines with a Purpose. It says that the human should never be subservient to machines and automation. It should be the other way. So think of a just appreciate the vision of a researcher. In 1990, when the robot started during the third industrial revolution, he appreciated the concern and told that the too much of automation will not be good for the society. And after 31 years later, the European Union is saying that the industry must be the human-centric, industry must be the sustainable, industry must be the resilient. So what Japan says in 2017 and European Union says 2021, the Professor Rosenberg told in 1990. What does it mean? That means we want a society which will be well-being. What is meant by that? It means that the human-centric manufacturing, more specifically, we want the productivity and also the workers' satisfaction. So when the productivity will happening, but without the worker satisfaction, which is happening right now presently at the industry 4.0 era in most of the cases, we do not want that development. Rather, we want the industry 5.0 concept, that the productivity with the worker satisfaction. So these are the three pillars of the industry 5.0, which is basically demanding a value-driven initiative. That means technological transformation with a particular purpose. That purpose will promote the talent, diversity, empowerment, and that particular purpose will also promote reuse, repurpose, recycling, reduce the waste, and at the same time to bring more and more flexibility into the manufacturing system, so that manufacturing systems or the industry would be able to cope up the unforeseen situations. So human centricity, sustainability, and the resilience, these are the three pillars of the industry 5.0 or the human-centric manufacturing concept. If I look into the human needs, every industry must think of these 5 needs of human being. And I'm in IIT as a faculty. I've observed, I've studied all these 5 needs, and I have seen that all these 5 needs, being in the academic institution also, I want. That means I want safety, I want the healthy working environment, I want the social cooperations, I want the recognition. Today you have invited me. I'm very much proud. I'm feeling good. So that's the recognition. And as a result, I would like to grow. At the same time, I would like to see the IIT also grows. So unless these 5, the features or the demands or the needs are met, the society or the industry cannot be the human-centric. That means you have to prioritize the human needs alongside the productivity and efficiency. You cannot go ahead purely the profit-based or the progress-based system. Like IIT system cannot always think of the ranking devoid of the workers or the employees, or the staff member or the faculty member or the students or all entities satisfaction. Similarly, in the industry cannot all the time thinking of this much of the profit, the turnover, but not concerned about the worker satisfaction. So we want a relationship between a human and a machine, which will not only coexist, which will not only cooperate, which will not only collaborate. Today we are doing that, but it must be compassionate, and at the same time, both the units should evolve. It should have the co-evolution feature. So that means safety, health issues, belongingness, esteem, and self-actualizations, which are the 5 needs, the mentioned by the great philosopher Abraham, must be mapped with the 5C ladder concept in the industry. That coexistence, cooperations, collaborations, compassionate, and the co-evolution. What does it mean? What is meant by the human-centric manufacturing? Human-centric manufacturing reference means that any relation must be having the empathy power, empathy skills. That means machine must understand human, human must understand or rely the machine. So there should be all the time assessment, risk assessment, like the fatigue, stress, like what is the physiological phenomena happening, what is the heart rate, brain activity. Can a robot understand that? Can a robot, when a robot will work with a human being, can a robot understand how much I am stressed? because I'll not be working with the same spirit or the energy 8 hours in a shift. And at the same time, the new person which would be joining for the next shift, he or she may not be having the same work spirit. So over a period of time in 8 hours and over the shift, there will be the non-uniformity. So how a robot will understand that and come up with a very generic or the holistic AI model so that robot can work very seamlessly, holistically with any dynamic working situation. You can program a robot, but you cannot program a human being. If an assembly job is to be done both by human and the robot together, robot will be doing the job with the repetitive nature with the high precision. But there will be a faltering situation by the active for the on the activity by the human being. So how to understand the dynamic situation? How to understand that the cognitive state? At the same time, what is the intelligence? What sort of intelligence I can deploy by the human being and by the machine? There should be activity which should be very, very smart, specific for the robot. There should be specific activity for the human being. Similarly, now when you get to have all this understanding, like the empathy skill, different types of the expert domain identification, there should be also a continuous dialogue. That means the communications. So how to understand the human thought process, that the emotion, brain signal by the robots. So how to capture those signals? Is it possible to augment deploy the augmented reality or the virtual reality in this activity? Can I get to have a sensor which will capture my emotion and also the personalized activity? So when we get to have understanding the empathy skills, when you get to have the proper intelligence identifications and get to have the proper communication mode, then all these things can be put together and bring back to the manufacturing domain. So when you study any manufacturing activity, in industrial activity, as I mentioned, that there will be millions of tasks, and each and every task is very, very specific. So we have to understand this. We have to basically list the activities, and from that listing, hierarchical activity task, we have to allocate some tasks to the human being exclusively, some tasks to the robot, which would be, the dull, dirty, and dangerous 3D task. It will be exclusively, it can be given to the robots. Humans should not do the mundane work. If you think of a worker, labor, if he's asked to do the same job repeatedly without putting any intelligence, just because he or she didn't have the proper educations at the time of employment, he or she is losing the opportunity of the growth, personal growth. So systems should be such that the activities which can be developed, can be very easily done by the robots should take away that activity. Industry should also be generating or coming up with the upskilling or the reskilling courses or the program, so that every stakeholders get an opportunity to grow. If you have that, then automatically there will be more and more belongingness, more and more esteem would be realized, self-esteem and self-actualization should also be perceived. So that's why, and some activity there will be the needing the collaboration. That need of the collaboration means the dexterity of the robots and the intellectual capability of the human. These two exclusive features of the respective ends of the robots and the human being, if we can bring the together, make it surfaced out, then there will be the actual collaborations. Otherwise, there will be always, human would be always doing the mundane work, and robots will be taking up the work of the human being, which is also very, very, the sophisticated in nature. Now, so as of now, if we observe very carefully, any organizations, any industry, it is the profit making, profit based or the progress based. That means industry wants which product I should come up with to sell into the market. But customers today want that which type of product I want. Industry is thinking which type of relationship I should maintain with the customer. And customer is thinking what sort of relation I expect from the industry. Industry is thinking how much money can be earned from the customer. And customer is thinking that what value a company can add to the customer. That means an organizational mindset, profit-based mindset needs to get changed to the human-centric mindset. Industry 4.0 is basically the organizational mindset. Industry 5.0 is the human-centric mindset. So that means, but it is not so easy. There will be the social challenges, there will be the technological challenges. We cannot depend today on the machine's reliability. We cannot depend on the intelligence, and it's a lifelong learning. So how to adapt the new technologies? So a lot of social challenges are there. At the same time, a lot of technical challenges, like how to embed the AI technologies and with the human need. Similarly, how to come up with the standard performance metrics, how to come up with an explainability concept of the AI system so that it can reason it out and then can be deployed for the more generic the situations and bringing transparency. That means social challenges are there, technical challenges are there, but still we need to gradually evolve. Now let us come to the second issue, that the sustainability. Sustainability, that means something which will keep on existing over a period of time. That means an industry, if it wants to be sustainable over the decades, over the generations, over the technological revolutions, it must be flexible enough to adapt these changes. Just like sometimes we tell the samay ke sath chalo. If we think that I am the most intelligent person and I will be surviving in the nature over the decades, then I'll be a fool. I'll be making mistake. If I think I am the strongest person, and definitely I'm going to survive, that is also a wrong concept. That means most strong industry, robust industry can also fail in future if it is not flexible enough to adapt the changes. And that's why you see that the small species, very small species in the photograph, this particular species is living on the earth from 220 million years. It is neither the most intelligent animal is the human being. It is neither the most strongest maybe the elephant or some other animal. So that means it's neither strongest nor intelligence, but it is surviving. That means it is constantly changing its feature. It is constantly changing its activity to be in the society or in the nature. So sustainability is nothing but the industry 5.0 is nothing but the industry 4.0 with the soul. As I've already mentioned, that industry 4.0 is purely on the digitalization, whereas industry 5.0 is the sustainable digitalization. I'm not saying that we don't want the digitalization. I'm not saying that we don't want the automation. I'm not saying we don't want the AI. I'm saying we want the technological development, but the technological development should be very much green so that it can make it sustainable. So that means when it can be sustainable, it can be sustainable if it can go, thought of based on the circular economy. If it is based on the usage of the alternative fuels or the materials, if it is based on the waste reduction. So technology should be such that the productivity would be high, but at the same time, it will be making use of the recycling as much as possible. It should be making use of the alternative fuels so that the nature is safe. So these features should be very much, the thought of. And that's why the research, like the development, technological development of the research should be based on these three aspects of the concerns. And that's why the United Nations has come up with the Sustainable Development Goals. And I'm pretty sure that you have heard of the SDGs, 17 Sustainable Goals. And if you see these 17 sustainable goals, what are the concerns, and the concerns which I have already mentioned, which is, accumulated concerns out of the industrial development, is exactly the same. We do have the gender inequality. We do have the concern of the clean water. And our country is technological growth is very high, but the economic growth is very high, but at the same time we are carrying the Bisleri water when we travel in train. That means we are unable to provide the clean water or the sanitization across the country. And we do have also the poverty. So what are the technologies? Is the technology low cost? Can it be deployed by the micro, small and medium enterprises? Can it reach to the common mass? Technology should be for the common mass. Technology should be such that our gender inequality is resolved. Technology should be such that which will help to bring the educations, quality educations across the 140 the crores of the people in our country. But at the same time, there is a promise. Out of 17 sustainable goals, people are thinking, people are appreciated that 10 goals can be very much possible to be deployed, the served by the technological deployment. As I mentioned, that the technology should be such that it can solve the society's concern. So 10 goals can be very easily served that. And 10 goals does include the electricity. So can I come up with an alternative source of energy? Is that the wind energy be possible to be made used to serve those 10 sustainable goals out of the 17 sustainable goals? Can the research be oriented to that? Can be AI brought into this, this activity? So there is a tremendous prospect. At the same time, adoption is also happening. If you see that the countries which are in the Nordic countries, that the Finland, Sweden, Denmark, Germany, and Belgium, where the human development index is very high, strong economic index, high social cohesion index, they are doing very good. They have already started deploying the SDGs. Now the European Union will also come up, the United Nations will also come up with the metrics that how much the sustainable goal mandate is being fulfilled by each and every the country, each and every organizations, and they'll be given some score. So we have understood the sustainability concern also. Let us look into the resilience. We have all seen the experience the COVID. During the COVID, we have seen that the many organizations, even big organizations, that stopped their productivity. Why did it happen? It happened because they could not anticipate that some disruptions is coming up, some danger is coming up. So if they could have anticipated and made the necessary changes within the infrastructure, using the own infrastructures and all, that means if they could have brought a little bit of the flexibility in the adoption, then they could have survived. So most of the industries were not resilient. I'm giving an example. I'm having an industry, I'm producing a product using the existing infrastructure. If I could think that the existing infrastructure can also be deployed for the production of something, that means the byproduct, in the off hours, and then that byproduct can also have a market. So if the market for the product goes down, and maybe a possibility that the market for the byproduct can also be used. Can I make my system which can also be made useful or the shareable to the others? And that's why if you do not want bring the flexibility or the adaptability, even the robust system will fail. Robust system, if you are not robust, if you are weak, if you are not flexible, will collapse with the unforeseen situation. If you are robust, strong, you may survive. But if you are resilient, changing your, the very flexible in adapting the changes happening, that means you are resilient. You can grow and grow and grow. So the anticipations and responding to the crisis, maintaining stability during the challenges period, and this point is also very, very critical, the support mutually and share the resource. If these things could have been, would have done, then the major industries in India and abroad could have survived and resilient. So if we understand the human centricity, sustainability, and resilience, as a researcher, I'll be asking, then what are the enabling technologies to bring that? There should be, this is irrespective of the industrial sector. It is applicable across the industrial sector, like the human-machine interactions, enhancing more and more, let's say, the flexibility or the adaptability in this system. Can I come up with more bio-inspired technologies? Can I come up with the development of the digital twins, like the digital version of the physical system? If you do have a critical component, you as a company owner, you might be interested to get to know what would be the health, in future for that machine. Or if a new process parameter, new job comes up, whether the machine would be capable enough doing that. So before executing that job, before doing that, you can get it simulated in your digital twin. That means the digital replica of the physical system. So if it is possible, then you can avoid the any sort of faulty or these disasters. And then what sort of technologies we can bring in to secure our huge amount of the data? As all of us know, irrespective of the the gender and then age group, we have passing through the time and experiencing that the every day we are gathering information. Every day, every organization, every human being, every society, and every community. So how to make this huge amount of the data coming from the different sources and then different format, and how to transmit it, get it transmitted to the different parts of the community at a very fast rate. You might be observe, all of us might be using the WhatsApp. Immediately we are capturing the image and sending it to our near and dear ones. You see that how fast an image is captured and shared across the community. And what would be the advanced AI model to bring all these things in place? So these enabling technologies, which is under the concept of the umbrella of the Industry 5.0, is coming up in a big way. Recently, I was surveying a lot about the research across the top universities in the globe in this particular field. Like I have also told my students, like when you are doing a research in a particular field, you must know what is the capacity or the level of research happening in your field, the globally. So you identify top 10 universities in your field and see where do we stand. If we stand, the below, then what are the causes? Are we lacking the resources? Are we lacking the intellectual capacity? So that what should be the measure so that we can reach to that point? So my students are working on that. I'm giving a little bit of hope that how technology can bring change our future. We all know we have used the 1G. 1G is used for in the telecom, the calling purpose. 2G, the SMS mainly. 3G, the emails. The 4G, the audiovisual. Today we are standing in the 5G era, Internet of Things. That means things means the physical entity. So physical entities are connected by the that means the internet, but that means the cyber. That means a lot of informations are coming up, and we are developing insight to that. So in the 6G, can I transfer my emotion? Can I transfer my emotion? That means the grandpa sitting in India can cuddle the grandson or the granddaughter who may be there in abroad. And then the granddaughter or the grandson can feel the affection of the grandpa. Is it possible? Can I have the concept called the Internet of No Things? That means that will not be physical things, but all would be made available in the form of a service. So these two concepts, it is not a very sci-fi today. It is a bit of sci-fi, but it's not purely the sci-fi. I'll give some examples on that. And very soon, maybe 5 years down the line, in my estimation, it would be, we'd be able to appreciate that 30% of these two new concepts are getting served. That is the tactile internet and then internet of the know things. Today, in Amazon, if you survey any product, you get to see the lot of the options. Next day you visit to that Amazon, they will give you the reminder that these are the things you have visited, whether you are really interested or not. Augmented reality has made it already possible that if you want to survey a product in the Amazon or the e-platform, then you can see it is three-dimensional view. And if I can get to have through the virtual reality concept or the augmented reality concept, bring that the sensation, like when you observe an object, like searching a garment or other things in the Amazon or in the e-marketplace, you can feel the texture of that garment. Today we cannot feel it. Today we see the 2D image only. Augmented reality is coming up to make it 3D form. That means you can see the entire product, all from all dimensions. You can rotate it and see it. And at the same time, if you touch that product, you'll get to have the feeling. It has got a tremendous, it would be a tremendous benefit for the doctors. It's a tremendous benefit for the doctors. Like if a doctor is doing surgery remotely, he or she would be able to feel the organ when the surgery is being done. But for the teachers, like, is it possible to beat a student online? But I am not going into that topic because the beating is not permitted. It is not allowed. It should not be entertained. We got beaten up by our teachers in our childhood school days mostly. But these days, the school children are not got beaten. That's a good thing, I would say. But there are a lot of benefits of this tactile internet and all. What is internet of no things? If I can have the service by not possessing that the device or the equipment, like if I want to go from one place to the other place, if I go to Calcutta and then move from one place to the other place, or in Bhubaneswar, I'll be hiring the Uber. Why should I take my car all that time and go to that place? If I want to watch a movie, why should I purchase that DVD? I can get it from the Netflix. If you want to purchase the same TV, same movie, why should you purchase or possess that DVD? If we start possessing the things by every individual, then what will happen is that the lot of productions will happen. And at the same time, a lot of concerns will be coming up, again dumping that thing, and then pollutions and all these things will be happening. Rather, if I can go ahead with the concept of the Netflix, if I can go ahead with the concept of the Uber, same car is being used, shared by the different people for their need. You don't need to possess it. If you don't possess, a lot of complexities will get solved. So that means the service, that means your demand would be serviced by little, or the no or things, the concept. So all these things can be made possible if we concentrate on these activities of the system, which should be very, very cognitive system. That means AI should, I've started with these, the 5 features only: the attention, memory, problem solving, perception, knowledge transfers, and all. So if I can develop AI model, if I can develop technology surrounding this, then situation, the days would be coming up that the industry 5.0 would be fully the served. So what to do finally? We need to have a proper strategic plan. We need to have a proper technology. We need to have the proper analytics. A lot of data would be coming up. We need to innovate all the time. We need to engage all people, irrespective of the gender, irrespective of the community. We should also engage each and every people in the system for their personal growth. All these 6, the concept are very much needed, be it in academic institute, research organizations, or the industrial perspective. As a society, as a community, we must have these 6 pillars. If we don't have the first one, that means the strategic plan. you'll be having the more of the digitizations. If you don't have the technology in place, you'll be having the frustrations. If you don't have the competence, then you'll have the anxiety. But if you do have all six, the concepts in place, then you'll have the industry 5.0 transformation. That means we'll get to have a society which should be human centric, which should be sustainable, which should be resilient. So that means what is the takeaway? Takeaway is that the human and machines must work together flawlessly, seamlessly, understanding the emotions of each other. And at the same time, they should evolve, together. That means what is the thought process? What is the stress level? What is the emotion going ahead in the minds of the co-workers if the robot can, do something for the human being? That's why the robot is offering a flower to the girl, to the female. At the same time, if we work together, understanding how we are working individually and can optimize our own activity. Both are dancing. Robot is dancing. Human being is also dancing. Human being is trying to follow how the robot is dancing, and human being is trying to change his dance pattern. So IIT Kharagpur, our Center of Excellence, we are all not sitting behind. Our robot is also understanding the human mind, and my mind is very, very complex. So if robot can understand what I'm thinking, whether I'm thinking the red color or the yellow color or the green color, robot is exactly going there and then picking up the object. There is no physical connectivity between my thought process and the robot. How it is getting done? I am just sitting in my lab during the COVID time. I am wearing an EEG headset. EEG headset is nothing but it is an electrode capturing the brain signal of my thought. When I'm observing red, brain is emitting some signal. So EEG, electroencephalogram, is capturing that signal, and robot is working for that. So we are working on these cognitive aspects. That is the tremendous amount of signal processing, data communication to the cloud, and robot actuation in the real time. Everything must take place in the real time, real deployment. I always tell my students and then the co-researchers that you can come up with an AI model, it's fine. You come up with a new technology, it is fine. But until and unless return on investment is the return on investment is achieved, the quick return is not getting done, and at the same time your deployment of the AI model is not happening within the cycle time of the productions, no industry will take up. More specifically, your technology has to be the low cost technology that you develop. May be good for the big industries where you have a big pocket, but the small industries, they do not have the big pocket, but they are also looking for the low cost technology. So as a researchers, our aim should be to develop the low cost society, low cost technology. Manufacturing GDP in India, 48% is from the micro, small, and medium enterprises, close to 48%. So see that how big is that number? And they are mostly on the jugaad technology. That means the industrial advancement has not pervaded too much. So if we, the researchers, do not bring the low cost technology for our Indian manufacturing, micro, small, and medium enterprises, I do not have any scare of saying that one day micro, small, medium enterprises in India will die in the global race, because there is no the technological advancement. Technological advancement deployment is a must for the product quality. These days, big industries, they get the supply from the tier 1 or the tier 2 companies, which are the micro, small, and medium enterprises, but their quality check is not that severe or that stringent. As a result, lot of rejections do happen in the OEMs. So I'd like to request all of you to visit physically. If it is not possible, then at least virtually our Center of Excellence. We want a 5C work frame. 5C work frame, as I've already mentioned, we should not only coexist, cooperate, collaborate, but we must be compassionate and co-evolve. This is the thought process at our Center of Excellence. And I'm a very small person in this big world, so you can get me through this this link. Thank you so much.
Thank you, Surjo, for excellent talk.
Thank you, sir. Thank you.
So we'd like to invite some questions.
Yeah, yes.
I would like to invite some questions from the audience, please. If somebody is having any question, they can ask.
Any question? Please raise your hand.
I mean, if later on, if you come up with any concern, anything, please let me know. I'll be answering through email also. No problem on that. Yeah.
So I think this the presentation is well understood, and definitely they would like to connect you in future, sir.
Yeah.
So I'm getting one Basa Jana has raised his hand. Please ask question by unmuting yourselves, please.
Yeah, very good afternoon to all of you, and many thanks to Professor Surjapal for this enlightening sharing of his thoughts on Industry 5. I know him since my Tata Motors days, and I think it has always been a pleasure to interact on various models and what he had been doing for the industry. But today was, of course, a very new thing that he talked about a human-centric approach that we need to bring in along with the industry-centric approach that we have been following till now. So thank you very much, Professor. And just wanted to, I liked your lot of examples, and the slides were too good. And it really caught my mind when you said that we as a society are failing to provide the clean, safe drinking water. And the example of that is in the Bisleri bottle that we all are carrying. Very true, very true. I see when I go to different hotels, like last week I was in a 5-star in Surat, in Bombay, sorry, where I saw they were using, bottled waters. I mean, they were replacing the water in the glass bottles. Whereas when I travel to Surat, I still see a lot of people using the plastic bottles, even in the hotel. So I see changes that are happening, but it's going to be slow. My question to you is, you said UN is coming with some metrics, right? So what are those? Can you please elaborate on what UN is developing for the world? If you could enlighten and elaborate, that will be helpful.
So there are the 78 protocols, that is called ESG, the sustainable governance and all.
Mm-hmm.
So these thing depends on the all aspects, like your resource, the active type of governance that you are happening, the making. So different types of the protocols are there. Based on the protocols, they will come up. Now they're framing the metrics. It's not the metrics is already done. They're framing the metrics as the literature says. So that would be mandated. So every industry needs to comply, that they will be providing those information, that how much they have fulfilled out of those the protocols. And it's gas, it is related to electricity, it is related to water supply, it is related to the alternative the fuel. So as an industry or organizations, what are the things you are doing? So those information should be captured, and then based on that, some calculations, some metrics, which I'm not very much sure that how the calculation should be done, but they are coming up with these metrics, which should be, the awarded or rewarded or the demanded to the industries to meet to a certain level. So this is going to happen. This is, based on these 17 sustainable development goals.
Okay, thank you so much. Thank you.
Yeah, and a lot of startups have also come up. In fact, we are working with one of the startups in USA. So they that is their software name is that Amprofly 4.0, which is on the ESG calculations. Now we are developing some portion of the software. I cannot disclose the entire thing as we have signed an NDA. So that software, if it is procured, every industry needs to feed the data, and it will calculate all these aspects, and then they will understand that how much they are reaching to the sustainable goal development activities. So that data needs to be given to the UN later on. But the metrics calculations is not yet formulated, as my understanding is very poor in that, I must admit. So what exactly, how the metrics is what will be the calculations and all, how the scoring would be done, that I'm not very much sure. But these are the concern that I wanted to say.
Okay, thank you so much, Professor.
Thank you. How are you? Fine?
Any other question? I have a silly question, Suju.
Sir.
How industry 6.0 will look like?
So I don't know, but industry will always be looking forward to the advancement, and the profit will definitely be there, and then humans should also be there in the industry. So there will be a lot of the cohesive thing. If the industry 5.03 verticals are made, I don't think there is any need of industry 6.0. It is not that the industry 6.0 or 7.0 things should be coming up. Actual, the UN, what it has mandated, the 17 goals. If you know very well that if those concerns are solved or served, there will not hardly be any concern in future. That's from the society perspective. And the industry, lot of no one can stop development of the technology. So new technology may come up. 30 years back, people thought that whether I can see the photograph of the people in the phone. Today we can do it in the WhatsApp. Now people have started thinking whether I can get the smell of the flower. That also research is going on. 6G is giving a hope that we'll be able to cuddle the babies, of our relatives, sitting far away. But the 6.0 industry 6.0, I don't have any idea what will be the beyond this.
Yes. Madam Renu Sharma, now you can propose a vote of thanks.
Yes, sir. Honorable Vice Chancellor, Shiksha Anusandhan Bhimtvi University, Honorable Professor Damodaracharya Sir, Chairman Advisory Board, SOA University, Chairman INAE Bhubaneswar Chapter, Director IIT Bhubaneswar, Director NISER, Director CSIR MMT, and distinguished speaker of today's distinguished lecture, Professor Suji Pal. A very good evening, and I, on behalf of INAE Bhubaneswar Chapter, Shiksha Anusandhan University, CSR MMT, IIT Bhubaneswar, and NISER Bhubaneswar, and IEEE Bhubaneswar subsection, it is my privilege to extend a heartfelt vote of thanks to Professor for delivering today's enlightening and thought-provoking lecture. Professor Pal's exploration of Industry 5.0 has both insightful and timely, shedding light on integration of human intelligence with cutting-edge technologies such as artificial intelligence and robotics. Sir, your explanation of the shift from the Industry 4.0 to more human-centric Industry 5.0 has provided us with a fresh perspective on innovation. Sir, by highlighting the three core pillars like human-centric innovation, resilience, and sustainability, we have underscored the vital role of human that they are playing in the creative decision-making while machines takes on repetitive tasks. I also appreciate and emphasize on cognitive artificial intelligence as a key enabler of human-machine collaboration, supported by real-world case studies from Center of Excellence Advanced Manufacturing Technology. Thank you, Professor Pal, for sharing your knowledge and expanding our understanding of the future of the industry. I also thank the distinguished guests, faculty, students, and organizing committee members for their support and participation in this successful event. Thank you all. Jai Hind. Namaste, sir.
Thank you so much.
Thank you, sir. Thank you.
Surya actually has spoken. What I should say, maybe a sort of gift will come to you
And
based on this one.
okay,
So,
thank you.
One more thing, can we really take a photograph? Those who are present, actually, they can.
They can open their cameras, please, so that we can have a group photographs.
Yes, please.
So after that, please share ma'am. Please share this photograph to me as well.
Sure, sir.
Anybody else actually? Others actually who are there, please. Okay, now you can take the photograph.
Thank you, sir. Thank you so much.
Thank you.
Okay. Thank you, Surya, so much.
Thank you, sir. Thank you.
Tomorrow, Sudasna is going to give a talk.
Yes, I have seen that. Can I leave, sir, now, ma'am?
Yes. Thank you so much.